Programmable materials, in HCI, has been widely explored on interactive physical properties, such as color, shape, and texture, as well as optical and magnetic properties. However, limited attention has been given to programmable thermal properties of materials. Existing work on interfaces with controllable temperatures either used electronics that continuously consume energy or relying on materials that passively create only one predefined temperature behavior via their interaction with ambient heat. These works both leave the gap of exploring objects that allow self-contained programmable temperature behaviors, utilizing materials' dynamic thermal properties. In this paper, we introduce Thermaterial, a method using fluidic composites to enable temperature behaviors without continuously consuming energy, instead utilizing programmed ambient heat transfer behaviors. By altering the fluidic medium within the fluidic channels, we can adjust the overall thermal insulance of the composites accordingly, thus programming the heat transfer effect through the material. We fabricated Thermaterial by first fabricating the substrate of the rigid or flexible fluidic composites, then installing the inside fluidic medium, including air and water. As an exploratory test with rigid substrate, we observe changes in the thermal insulance of up to 3.0 times, which is comparable with related studies in material science. Using Thermaterial, we explored 4 applications of objects with programmable heat transfer behaviors, including reconfigurable passive thermal markers that can display both visual and reconfigurable thermal data, potentially used in thermal inspection of industrial instruments. Tunable thermal wearables that can adjust the cooling skin contacting temperature, benefiting scenarios such as injury therapy, especially when users require customized cooling temperatures over time, according to personal physical conditions. Customized thermal-insulated layout in a container that supports heterogeneous temperature patterns inside a container, providing a low-tech approach for preserving temperature-sensitive items, such as food or medicine. And dynamic thermal-insulated enclosure that can alter the thermal conductivity of the enclosure to mitigate the internal temperature fluctuation in devices, which experience varying inner heating power or fluctuating ambient temperatures. For more details, please refer to our paper.